So ESG stands for environmental, social, and governance and refers to a company's commitment to do more than making a profit, such as actively striving to contribute positively to the environment or society or govern properly. Now let's talk about environment. As per the latest studies, mankind approximately has 6 years as of today to be able to limit the global temperature rise by 1.5 degrees centigrade by 2100. So why is 1.5 degrees so important? The probability of a sea ice-free Arctic Ocean during summer is substantially lower at a global warming rise of 1.5 degrees centigrade as compared to 2 degrees centigrade. Now, BlackRock, one of the top 5 trillion-dollar fund managers of the world, has estimated that the impact to the world economy due to increased temperatures will be in trillions of dollars. Simply put, one cannot treat environment or planet Earth as a garbage dump anymore. Coming to the social, labor strikes or consumer protests can directly affect a company's profitability by creating a scarcity of skilled employees or controversy. Corporations that ensure their products and services do not pose safety risks have much more sales. For example, Walmart became a more palatable choice for socially minded investors after it announced in September that it would restrict the types of firearm ammunition that it sells. Now, coming to the governance, in terms of governance, we have seen latest tech unicorns such as WeWork and Uber getting a bad reputation due to not following proper corporate governance norms. Volkswagen's emission tests and Facebook's misuse of data and other recent incidents have caused significant financial damage to these companies. So in the face of companies' missteps and expanding awareness of global diversity and income inequality, corporate governance is a core component of ESG. Due to all these reasons, we can also say that ESG has now become the new CSR and hence really important. Since 2006, clean tech startups have attracted $25 billion in VC investment till 2011. By the end of 2011, clean tech sector underwent one of the worst boom and bust cycles in the history of technology investing. Of the $25 billion that investors placed in clean tech firms, more than $12.5 billion was lost during what is retrospectively known as Clean Tech 1.0. The resulting carnage scared an entire generation of investors away from the sector. In our case, we are not trying to invest in any new form of energy or trying to completely change anything. All we are trying to change is human attitude towards timely maintenance requirements of their motor-driven equipment. And we are surrounded by motor-driven equipment. The attitude that is pervasive, that is reactive or preventive maintenance, is transformed by predictive maintenance that itself will save significant carbon emissions without a need for any new expansive innovation. Thus, we are confident that ours is a totally different and conservative approach which does not require a whole lot of capital investment and hence not significant risk from either our investors or our customers. All it needs is a shift in human mindset towards proactive maintenance, and we are willing to work with our end users towards that, and we will basically make sure our insights and notifications are sent in a way that it helps users in shifting that attitude. So Energy Monitor is our new product, and it includes all the features from our existing product Rotation Live, which is basically condition monitoring of all the rotating machinery. And in addition to Rotation LF, now this Energy Monitor will also track energy consumption patterns for motor-driven equipment over multiple days, weeks, or months. So basically, it is condition monitoring software plus energy efficiency software. It does not tell the absolute power consumption value in kilowatt hours, but enables the user to know the increase or decrease in power consumption due to some kind of a mechanical, electrical, or structural fault. Energy Monitor will enable the end user to keep the track of energy consumption due to particular fault mode. It gives total increase in power consumption across multiple motors, across multiple plants for a specific enterprise. It also gives what are the CO2 emissions increase due to that energy consumption increase throughout the enterprise and for every single plant. And apart from that, it also provides how much CO2, how much that CO2 emissions translate to. For example, how many gasoline-powered cars it puts off the road for a year if they take maintenance action at a right time. How many plants or acres of forest grown for 10 years is equivalent to this much CO2 emissions sequestered, and how much pounds of coal burned they are avoiding by avoiding these CO2 emissions by taking maintenance at the right time. So how does all this help an asset-intensive entity to meet their net zero goals? Net zero means that an enterprise either emits no greenhouse gases or offsets that completely. And with this solution, now they will be able to understand how many seedlings they need to grow, or how many cars they need to avoid, and how can they convert, how much they need to convert from coal to natural gas, renewable energy, or even nuclear energy. So this way they can meet their net zero goals. It comes back to fundamentals of physics. For electric AC motors, power consumption is directly proportional to the square of magnetic flux. This is electromagnetics 101. Currently, we are already using our magnetic flux data to extract RPM, or the speed of the machine, using machine doctor sensor with more than 98% accuracy for any machine with RPM between 100 to 6,000. This has already been tested in a laboratory of one of our strategic partners, which is a billion-dollar company. Machine doctor sensors can capture high-quality magnetic flux spectrum data, which have been validated on live machines. When installed at an appropriate location on the motor, it can show electrical line frequency, which is basically 50 Hertz. In many countries, it is 60 Hertz, clearly on the spectrum. Due to these two reasons, that is, by being true to the laws of physics and by ensuring high-quality magnetic flux data, which we have already validated, we are confident that we can achieve what we are claiming. All we require is an appropriate location on the motor to install the sensor without being disturbed over the course of this project. So Energy Monitor is now ready to be deployed at scale in the field, providing a cost-effective means for every company to achieve a greater sustainability. Just imagine the building we are in right now, 60% of it, energy consumed by it is consumed by motor-driven equipment. We are talking about saving at least 10 to 20% of that energy just by proper and proactive maintenance delivered through Energy Monitor. We're talking about impacting 2 to 3% of total global carbon emissions, right? Apart from that, in the industrial sector, where almost 50% of energy is consumed by motor-driven equipments, again, we can save up to 10% of that energy. That means 2 to 3% of total plant's energy just by proper condition monitoring. All of this possible with insights from Energy Monitor, allowing maintenance and reliability professionals to take appropriate actions at the right time. Of course, it needs proper cooperation between the site team and us. It is not just that one software will do the magic. It needs a collaboration for this number to be achieved. We have constructed our dashboard in a way that it now shows energy lost and also carbon emissions because of any fault modes in the machine. And this incentivizes the user to take to weigh their priorities, whether to postpone the decision till the last moment just to avoid a production loss, or they can prepone and take some hours of production loss to save this energy consumption and associated carbon emissions due to some fault mode in the machinery, right? If the production is indeed critical, then a production process cannot be stopped, but that's a decision the user can take. But before, they didn't have this data, so everyone was, all the users or customers that we see were only focused on avoiding unplanned downtime. But now with this data, they can prioritize better. With Energy Monitor, we can significantly contribute towards this net zero goal for not just individuals, but for residential buildings, industrial plants, by monitoring power consumption of the motor-driven equipment. All this without changing anything except human attitude towards the maintenance actions triggered by Energy Monitor for the motor-driven equipment. So energy use in buildings and industries together is responsible for 42% of the total carbon emissions as per Climate Watch. And motor-driven equipment, which we are monitoring, is responsible for 60 to 70% of the total building electricity consumption and plant electricity consumption. Now, we're talking about impacting 2 to 3% of global carbon emissions just by advising right maintenance at the right time for motor-driven equipment. Isn't that a noble enough goal to expand from just doing condition monitoring to providing condition monitoring-based energy efficiency insights? Ultimately, we are changing nothing much in our hardware and software, but rather the attitude of the people who are operating these equipments towards the maintenance of those equipments.